No? Share. Yes, are you able to see the slides?
Yes, sir.
Yes, sir.
I'm changing.
Yes, sir.
Okay. So, welcome to Department of Chemical Engineering, Banastali Vidyapeeth. We are on something special today to begin with. Let's have it going. Women in chemical engineering. Women in chemical engineering. Paula Teresa Hammond is a David Head Coach Professor in Engineering and is the head of the Department of Chemical Engineering at the Massachusetts Institute of Technology, MIT, Boston. MIT Boston is a mecca for chemical engineers and it is headed by a woman, Paula Hammond. Matter of pride. Oh, next, Jennifer Sinclair Curtis. She is Distinguished Professor of Department of Chemical Engineering, University of California, Davis. She had been Dean also, had been. Presently, she is Distinguished Professor, University of California, Davis. Yet another woman chemical engineer leading the light. Oh, we have Cynthia Murphy Ortega. She is manager, Chevron University, Partnerships and Association Relationships. I'll be reaching out to her shortly. Cynthia Murphy Ortega, Chevron, the oil major, and they run a university, Chevron University. And Cynthia Murphy Ortega, chemical engineer, is the manager there, working out partnerships and association relation. Oh, Rosemary Wesson. She is the Associate Dean of Research at City College, New York. She was the first African American woman to receive a PhD in chemical engineering from the University of Michigan. Rosemary Wesson, a name to reckon with among women in chemical engineering. Last but not the least, Alice Petrie Gast. She is an American researcher. She is the 16th president of Imperial College London. Imperial College London is the Adda of, let's say, Nobel laureates, Imperial College London, and Alice Gast is the president of that Imperial College London, and she also sits on the board of directors of Chevron, another chemical engineer name to reckon with. So we had Alice Gast, Rosemary Wesson, Cynthia Murphy Ortega, Jennifer Sinclair Curtis, Paul Teresa Hammond. I think it's time for us to hear from each one of them as to what they have to say to you. Let's get going. Let's just hear what they have to say to us. Are you able to see the video?
Yes, sir.
Yes, hear it.
It allows a place for women to provide advice to each other and to inspire each other. And that has always been important. By coming to AICHE and having the women here as a resource, that was like heaven. It was, you got a chance to see other people that were similar to you. You got a chance to speak with people who had been through what you're going through. And you got a chance to make other friends across the country that you can.
One of the keys is more leadership training, having more leaders in the academic field. We now see a lot of influx, more of women assistant professors moving up through the ranks, but you don't see a lot of women in leadership roles, whether that be dean, provost, president at universities, and the same in the industrial world with CEOs.
And what we need is not necessarily more women in engineering. We need more women that feel passionate about going into engineering and know that there are other women here. My hope would be that in the next decade, we can get at least a little closer to equity and representation of women in chemical engineering. Because when we have that level of representation, we begin to influence the way that we build things, the facts, and also the kinds of problems that there's certainly more opportunity for women to take up roles to
make it clear when things have been made more exclusive, not inviting women.
AICHE provides a number of ways in which it supports women. It is actually one of the most important ways because providing that space and allowing us to help each other and to mentor is one of the biggest things you can do to improve our career.
Not only can I find role models in it, but I have the opportunity to mentor younger female colleagues. And like I said, we have shared career goals, we have shared personal experiences being a woman in academia or in that you really not find other places.
I'm saying to women, try for it, go for it, apply for it, put yourself out there so that we can move you up.
And that's what I would say to young girls, that you can do anything you want to do with emotion.
Oh, that's it. Okay, so let's get back to so we saw the handful of chemical engineers, Alice Gass from President Imperial College London, Rosemary Wesson from the City College New York, Cynthia Murphy Ortega from Chevron University, Jennifer Sinclair Curtis from University of California, Davis, and Paul Theresa Hammond from MIT Boston. Great women chemical engineers. Would like to see some of you reaching such great position in the coming years. Get inspired. Okay. Now we are on to CHT 305 Chemical Technology, lecture number 26. Here we are on petrochemicals. I've deliberately chosen this figure, red hot. Petrochemicals is red hot because everything around us involves some petrochemicals. So, something very interesting about petrochemical is technology is not big, but the politics and economics associated with petrochemicals is something bigger. We can master technology, but we should get the hang of what are the economics and politics that is there with petroleum and petrochemicals. Okay, before that, we already saw in the last lecture, time has come to do refinery petrochemical integration. See, earlier refineries were meant primarily to generate fuel like petrol, gasoline, diesel, kerosene, etc., jet fuel, which drive the transportation industry. But with switching over to alternate fuels, biodiesel, hydrogen, and electric cars. What's happening is slowly the refinery is getting a new look. Whether refinery should stick to the business of making fuels for the industry or make chemicals for the petrochemical process. So you can understand refinery petrochemical integration has to happen, if not today, maybe if not tomorrow, maybe day after tomorrow. But for sure it has to happen. The growth of the petrochemical industry has put pressure on refineries to either change their configuration or operating condition to produce more aromatics and light alkenes. See, right now, industry refinery is not interested in making ethylene propylene because ethylene propylene are unsaturated hydrocarbon, which is not desirable in the petrol, diesel, kerosene, etc. Because unsaturated compound they form gum-like substance during the in the engine and is not suitable. So already we saw that in the refinery may have a small option of polymerization by which the ethylene propylene may be made into a dimer trimer and blended with gasoline as polymer blend of gasoline. But that's not big business, right? The bigger business is convert the ethylene propylene into polyethylene, polypropylene, and there is big money out there. And why do the what is that catalytic reforming to make benzene, toluene, zoluene, xylene for blending in the petrol as a reformate blend? I would rather use the benzene, toluene, and xylene to make a whole thousands of petrochemicals. The fluidized catalytic cracking process has been developed to Petro FCC. In fact, the fluidized catalytic process produces ethylene propylene, which is then sent to the petrochemical industry. So it is actually already a Petro FCC, you can say. It produces a high yield of gases, especially in the Middle and Far East countries. Furthermore, the phasing out of the idea of increasing the octane number, ये कब तक हम लड़ते रहेंगे ऑक्टेन नंबर के साथ, बढ़ते जा रहा है, right? And more the powerful engine, you want more octane number and you start blending, more and more things. So it's time to put an end to the octane dream and freeze it and start doing more of petrochemicals, right? So let's not put the benzene, toluene, xylene as a reformate blend for octane number improvement of gasoline, but we will use benzene, toluene, xylene to make a lot of organic chemicals, which are the petrochemicals. Petrochemical, by definition, means they originate, their raw material comes from oil or gas or the refinery product. Okay. In addition, the installation of gasification unit to process vacuum residue. Remember, vacuum residue was almost a kachara in the refinery, as a condemned waste, but I can do gasification of the vacuum residue, partial oxidation, like coal gasification. I can do partial oxidation of the vacuum residue and make it into syngas, carbon monoxide and hydrogen, and make whole lot of petrochemicals out of it, because carbon monoxide and hydrogen can be used to make methanol, and from methanol we can jump to many other chemicals, right? Or I can use the vacuum residue to make ammonia also, syngas, nitrogen and hydrogen, so that I can make ammonia, right? So a whole lot of options are opening up. We already saw the trend in year 2010. Look at the red line denote the petrochemical demand and the green line denote the refinery product. The refinery products from 2010 to 20 have very marginally risen. From 20 to 40, almost they are a little above, but more or less a plateau. Plateau means very flat, right? And look at the petrochemical. 2010, zoom. 2020 upper, 2030 or higher, 2040 still high. This is a prediction by international consultants, IHS, right? IHS is a name to reckon with. IHS Market is a renowned consultancy organization which does forecasts of the industry. Okay, so you can see that petrochemical product, that's why I showed you a red hot plant of petrochemicals, red hot, right? How do we do it? So in the refinery, I have a reformer, I have FCC coker, fluidized catalytic cracking or coker, right? Coker means, with braking, delayed croaking, flexi coking, etc. Right? So I get propylene, right? And from the reformer, I get benzene, toluene, xylene. And from the refinery, I also get ethylene, right? So you can see that from the ethylene, I get no propyl. I mean, I get all the product from the cracker, ethylene, propylene, butadiene, right? And from the refinery waste product which we will use as fuel oil, right? And from the benzene, toluene, xylene, I get benzene, toluene, xylene. So this is the emerging scenario, refinery to petrochemical integration, emerging scenario, right? And let's come to some politics and economics of petrochemicals. You'll be surprised to know, let's take two countries in the world. The United States of America, which is everybody's dream to live, and China, everybody's not dream to live. Two extremes. But let's have a look at both these extremes. In the year 2000, it is not mentioned here, I'm just reading out the statistics for you. In the year 2000, the United States of America had 22% of the global demand for top 10 major polymers. So, top 10 major polymers had a global demand of 22% in USA in 2000. And in year 2000, the demand in global demand of China was just 15%. USA was 22% and China was 15% in year 2000. And now let's see. Now, currently, China is 38% of the global demand of the top 10 major polymers, 38. And USA is only 10%. China has jumped in its demand for polymers, multifold, pushing USA behind. USA was 22% in 2000, and now it is 10%. And China's global demand of polymers was 15%, and today it is 38%. That is the politics and economics of the global countries. You can see where India will fall, will come to it. Also, per capita consumption is considered as a very significant factor in deciding how developed an economy is. Per capita consumption. Now, I'll tell you that per capita consumption of polymers are mainly petrochemicals, okay? Per capita consumption of polymers in year 2000 in China was 16 kg. Means a Chinese used to consume 16 kg. Consume means not eating, is using, right? So the total polymers in China divided by the population of China, it was 16 kg per capita consumption in year 2000. And that time, in year 2000, the USA's per capita consumption was 107 kg. You heard it? China's per capita consumption was 16 kg. China's per capita consumption was 16 kg in year 2000, whereas USA was 107 kg. And today, 2020, China's per capita consumption is 76 kg and USA is 89 kg. So China has jumped from 16 kg to 76 kg and it is growing. And USA was 107 kg per capita consumption of polymers in 2000 and now it is 89 kg, dropped by 20. And China has increased by 5 times. Say. India. India is fast emerging as a global hub for petrochemicals. With its high demand growth, India is projected to contribute to more than 10% of the incremental global growth in petrochemicals over the next decade. So we are there somewhere 10%. Compared to China, say 38%, India will be about 10%. And given the significant import dependence, India could potentially need more than 15 world-scale petrochemical assets by 2035 to meet domestic demand. So India should have at least 15 world-scale petrochemical plants by 2035 to meet the domestic demand. However, India's golden age of petrochemicals will be set in an uncertain global petrochemical landscape marked by a growing wave of global trade uncertainty, increasing regulatory focus on sustainability, circular economy. Circular economy means, cradle to grave, right? Everything goes round and round, right? And potential buildup of excess global supply of several vital chemistries. So we are going to have something great, but in great uncertain circumstances. Already 2020, we have seen the corona pandemic, right? So more uncertain time, but still, there is hope for great things to happen. The petrochemical sector is projected to emerge as a primary driver of growth for all global oil and gas sector, accounting for more than a third of incremental oil and gas demand by 2030. So it is petrochemicals which is going to drive the growth of the oil and gas sector. This trend is being driven by the overall growth and profitability of petrochemicals, around 3% CAGR over the next decade, right? And stagnating global demand for fuel, 1% CAGR. So you can see that petrochemical is now 3% of CAGR, 3% CAGR, whereas fuel is only 1% CAGR. So petrochemicals is on the swing. You already saw the graph. The fuel demand has more or less flattened in a plateau. This trend, along with the evolution of new crude to chemicals, now it is not crude to petrol, it is crude to chemicals. Technologies is accelerating the shift of oil and gas majors away from refining, with petrochemicals now accounting for 40 to 80% of the new refining assets. So more and more refineries are focusing on production of petrochemicals rather than increasing the petrol, diesel, kerosene, jet fuel. Within the petrochemical space, the past decade has been marked by the rise of China. I already told you, China is now having how much global demand of top 10 polymers is 38% is in China, whereas USA is only 10%, right? And stagnant demand in developed regions such as US and Western Europe. US and Western Europe, they are looking at, alternate products, and China is booming with the petrochemical, right? Has helped Asia emerge as a global petrochemical hub. See, earlier US and Western Europe was the hub of petrochemical, and today it is now switched over to Asia, right? And there is stagnant demand in US and Western Europe. However, the global petrochemical landscape continues to face uncertainties, including the recent wave of global trade restrictions. There are many global trade restrictions, growing environmental headwinds, everybody is raising a finger at, refining and refinery product, right? And emerging circular economy. Again, circular economy is something which is being talked where you have the concept of cradle to grave, right? So that everything goes round and round, right? Circular economy megatrend and rising bans on single-use plastics. You have already seen, right? Single-use plastics nobody wants, right? It's almost banned, condemned. Over the next decade, the majority of new capacity in the sector is projected to be in Asia. Around 65% of new global capacity, right? All the new petrochemical plants are expected, 65% of them are coming up in Asia, which will help the region reduce its current level of import dependence. So a lot of Asian countries are importing petrochemicals from other countries. So the new petrochemical plant will reduce the import dependence, right? This growing Asian capacity, coupled with significant expansion plans of selected players in US and Middle East, driven by their feedstock advantage. Remember, US and Middle East, they are both oil and gas rich, and they can keep expanding their chemical production, right? Is expected, projected to create excess supply across different chemistries. So there will be a scene of excess supply. This evolving supply demand landscape could potentially disrupt traditional petrochemical trade routes and market setups, right? So when demand is in some part of the world and supply is from some other part of the world, global politics, and we have a lot of disruptions expecting to happen, right? Amid this growing global volatility, India's petrochemical sector has emerged as an island of hope. Wow. With its significant import dependence and high demand growth, remember, our petrochemicals is largely imported, but we have a high demand growth. Our demand is growing. India has emerged as one of the world's most attractive markets for new petrochemical investment. The big names are ready to put money in setting up petrochemical plants in India because demand for petrochemical is on the rise in India. With the demand growth projected 8% CAGR over the next 15 years, amazing 8% CAGR over the next 15 years, compounded annual growth rate, right? India will contribute to more than 10% of incremental global petrochemical growth in the next decade, and will need more than 15 world-scale petrochemical assets by 2035, which we had just mentioned, right? So where is this? 15 world-scale petrochemical assets by 2035. Given the strong underlying demand trend, and India's petrochemical sector is now witnessing a significant investment boom with several multi-billion dollar assets either already on stream or expected within the next few years. First, both refiners and domestic petrochemical players are expanding their petrochemical capacity, while Reliance and IOCL, Indian Oil Corporation, have expanded the petrochemical production in the past couple of years. HPCL Mittal, Bhatinda Refinery, HPCL and Mittal Energy, Mittal, Steel, big name, Lakshmi Mittal, right, HMEL, right. So this is a joint venture, HPCL Mittal. This is expected to quadruple its petrochemical capacity over the next couple of years. Second, new domestic players such as ONGC Petro. This is a new partnership of ONGC to make petrochemicals, ONGC Petro additions, right? And that is known as OPAL, right? And Deepak Phenolics, recent entrance in the petrochemical space. So Deepak Fertilizer was a known name from Maharashtra, and now they are moving in a big way into Deepak Phenolics. In the next 3 to 5 years, HPCL Rajasthan Refinery Limited, HRRL, and Bharat Petroleum Corporation, BPCL, will join the list with their refinery integrated petrochemical assets. Wow. So a lot of exciting things are happening in the petrochemical sector. Finally, international players have also announced partnerships to enter the Indian market. Over the past 3 years, global firms Saudi Aramco, Rosenfeld, Nayara, BASF, Borealis have all announced plans to invest in Indian petrochemical manufacturing. Importantly, the mammoth 18 million metric ton MMT million metric ton West Coast refinery is being planned as a joint venture between Abu Dhabi National Oil Company ADNOC, Saudi Aramco, IOCL, BPCL, and HPCL. So there is a huge joint venture of big name Abu Dhabi Oil, Saudi Aramco, IOCL, BPCL, HPCL, all putting their heads together for West Coast refinery, 18 million metric tons. This venture could significantly alter the face of the Indian petrochemical landscape. Okay, now 5 characteristics of the Indian petrochemical market. Remember, why we are discussing this is the reason being petrochemical technology, we can go through it, the remaining lectures. But what's happening in the petrochemical industry should be absorbed by you so that you get the feel and importance of the industry. That's why we are discussing these topics. 5 characteristics of India's petrochemical market. We are oligopolistic, commodity-led market. You have studied principles of economics. You must have heard of monopoly, oligopoly, and pure competition. Monopoly means just somebody is dominating the entire industry. Oligopoly means just couple of players, 2, 3. And pure competition means lots of them fighting each other. And India's petrochemical is oligopolistic. Means not very many players are there. Refinery integrated capacities, these are characteristics. Complex sales and marketing setups, which makes our petrochemical market different. Price sensitive market with low realization. Price sensitive. Our population is highly conscious of price. Slightly more, avoid. Right? Tariff and duty barriers, taxes, whatnot. So let's have a look at each of these characteristics. Oligopoly commodity. Only a handful of domestic companies have dominated the petrochemical market. Reliance and IOCL currently accounting for 70% of domestic production of petrochemicals is only by Reliance and IOCL, Indian Oil. India's petrochemical players have mostly evolved their portfolios from legacy refinery setups to drive higher net realization. Legacy, Virasat, right? As a result, the focus has been on basic commodity chemicals where technology licenses have been readily available. Basic commodity chemicals, right? We'll see. These are all we are going to see, right? This was limited domestic production to mainly BB plus 1, BB plus 2 derivatives. That is 1 or 2 levels down the molecular chain from one of the basic building blocks such as ethylene. Building block, BB plus 1 being carbon, 1 carbon, 2 carbon derivative, right? And Reliance has focused primarily on polyethylene, polypropylene, PE and PP. Polyethylene PE and polypropylene PP. Polyethylene terephthalate, PET. Please be clear about these abbreviations. They are very essential for chemical engineers to know. If you say PET, it doesn't mean you are PET. It is polyethylene terephthalate. Polyvinyl chloride, PVC. These are all dominated by Reliance as one, evolving them as a one-step downstream expansion from its refinery operation. So from the Reliance refinery, one more step, you get polyethylene, refinery produces ethylene, you have a polymerization unit to make polyethylene. Refinery produces propylene, you have a polymer unit to make polypropylene. And refinery produces the raw material for polyethylene terephthalate, you just have to have one unit, right? So this is just one step downstream expansion from the refinery. As a consequence of this industry-wide strategy, capacities have been limited for downstream derivatives, especially intermediates and specialties, which continue to be served through import. Right? Many of the intermediates are chemicals which are not directly used, but they are used, to make other chemicals which will end up as products, intermediate. Refinery integrated capacity. A large proportion, around 80% of India's petrochemical industry continues to be refinery integrated due to limited feedstock availability. Refinery integration has been a key source of cost competitiveness over the past decade and has also been a key driver of the oligopolistic structure discussed earlier. This contrasts with other regions such as Middle East and US, where abundant gas supply has led to significant contribution from standalone petrochemical assets. Now you see, this refinery integrated capacity means only when my refinery works, from the refinery I go to petrochemicals. So if my refinery integrated, meaning that my capacity for petrochemical is dependent upon the capacity of the refinery. But in the Middle East countries and US, gas is abundantly available. So instead of refining, the gas is directly used for making petrochemicals. Gas means mostly natural gas, is methane. And from methane, I can make carbon monoxide and hydrogen, methanol and whatnot. Anything I can think of, CO and H2. No wonder they are called syngas. Right? So they are standalone petrochemicals. So using the gas, I can directly make the petrochemical, whereas in India, the gas is not abundant. So we are stuck. The refinery, how much it works, and a fraction of it goes for the petrochemical industry. Given this level of refinery integration, India's petrochemical players have largely maintained similar value proposition in terms of product range, pricing, channel partners, supply chain, and marketing setup. Now you can see the business aspects of petrochemical. So we are confined by the refinery operations. So we are not standalone petrochemicals like Middle East and US, where they use natural gas as a raw material for making petrochemical and not dependent on the refinery. Our complex sales and marketing setup. India's complex system of sales and marketing for petrochemical can best be described by the following four. We have a fragmented customer base. Demand is more in some parts and demand is very less in some parts. It's not a uniform demand. Our customer base is fragmented. India has more than 30,000 plastic processing companies and most are small, medium enterprises, small quantities. 30,000 plastic processing companies, but no world-scale large one. We're all small, medium enterprises. Credit-intensive market. A sizable proportion of India's SME, the small, medium enterprises, they have a cash problem. There is not a lot of money available with them. If they had money, they would have made a big unit, right? They are stuck to cash, assets, right? A sizable proportion of India's petrochemical customers have traditionally not had access to formal lending systems. Banks are not very ready to, they are ready to give money to big players. Banks are hesitant to give to small, medium enterprises, right? They think that they may not survive or they may not be efficient, right? So they have depended upon informal system of credit extension, meaning some type of, credit extension, that is, you take some money from a lending agency and you sell product to somebody with some credit and later payment facilities, etc. These are cash flow problem in the small, medium enterprises. Our unique channel setup, this is another, the way we have our distribution. India's petrochemical market is served by multiple types of channels, not only across various petrochemical categories, but sometimes within a category also. For example, there are three modes of polymer distribution exist in India. Del Credere Agent, DCA, Del Credere Agent, traders and dealers, and direct to customer model. So these are agents who take it and then they market it. Traders and dealers, they procure and then they deal with that. So these fellows are not companies, they are only agents, right? In turn, they may reach to traders and dealers, and there's very little direct customer model. So our channels of distribution is also very complex. Tight control over pricing by producers, right? Almost everybody ensures that the price control is in a very tight rope. Price sensitive market with low realization. Indian petrochemical prices are typically based on import parity, meaning how much at what suppose at what cost I am importing, I will try to sell so that people will not the imported product will not be cheaper than my cost, right? And they tend to move in tandem with other Asian markets. In the past few years, due to addition of significant new capacity, domestic prices have switched over from being import parity to import parity discount for select products such as polyethylene and polypropylene. So we are now not too obsessed with the imported price, right? So let's say at some cost we are importing polyethylene and polypropylene. Earlier, our manufacturers were betting or putting their price based on the imported price, right? But now we are ready to come out of it, import parity discount, right? And as a result, global players are now getting lower netbacks in India compared to other regional markets such as China and Southeast Asia. So the global players are now getting less because we are now pushing it in a more aggressive way, right? Tariff and duty barriers. The Indian government has introduced several types of duties, import duties, anti-dumping duties, additional taxes on imports of petrochemicals to protect the interests of domestic producers. So to protect the industry interests, the government keep putting taxes so that the import will become costlier and costlier. More import duty, the imported product will be more. Anti-dumping means some country cannot make it cheap and dump it in India and kill the Indian industry, right? So these are all safety measures by the government to see that the domestic producers don't suffer. The duty structures evolve constantly as a response to prevailing domestic and global market scenario and tend to significantly impact the competitiveness of domestic versus imported product. Now you read this. This is very interesting. Customs duty on PVC, polyvinyl chloride, where 60% of the annual demand of 3.4 MMT is met through import. So polyvinyl chloride, roughly 60% of the quantity is by import, right? And the customs duty was increased from 7.5 to 10% in 2019. Right. So the customs duty was increased from 7.5 to 10% in 2019, which makes the imported PVC costlier. This changed the margin dynamic for domestic players almost overnight. Just one change in duty from 7.5 to 10% boosted the sale of polyvinyl chloride by Reliance and other companies. Domestic players boomed overnight with this just one tax, 7.5 to 10% import duty, customs duty. Okay. Now look at this figure. This is in year 2019, petrochemical import versus demand, right? Total consumption is in metric ton, right? This is the net import, and this is the, where is this? Total consumption in 1000 metric tons. This is total consumption. Okay, now there's a whole lot of chemicals floating there, right? PS means polystyrene, PET is polyethylene terephthalate, VCM is vinyl chloride monomer, LLDP is linear low density polyethylene benzene. HDPE is high density polyethylene. MEG is monoethylene glycol. Methanol. PVC is polyvinyl chloride. PP is polypropylene. And PTA is PTA. Just check here. It should be in this list. Purified terephthalic acid. Right. So the abbreviations are all given in the subsequent slide. Right. So C1 is methanol, C2 is ethylene, C3 is propylene, C4 is butadiene, aromatic benzene, toluene, xylene. PBr is polybutadiene rubber, SBr is styrene butadiene rubber, ABS is acrylonitrile butadiene styrene, ABS, acrylonitrile butadiene styrene rubber, MEG is monoethylene glycol, VCM is vinyl chloride monomer, PVC is polyvinyl chloride, PET is polyethylene terephthalate, PTA is purified terephthalic acid, PP is polypropylene, PS is polystyrene, LDPE is low density polyethylene, LLDP is linear low density polyethylene, HDPE is high density polyethylene, MD is methylene diphenyl diisocyanate, TDI is toluene diisocyanate. I think they are all used for making those urethane foam. PC is polycarbonate. SAP is super absorbent polymers. The bubble size represents India's market size, net imports. Right. So you come down here. It is in year 2019 for all these chemicals. The figure shows the consumption and the net demand. Okay. So the size of the bubble is representing the Indian market in 1,000 metric tons. This is in 2019. Now let's look at 2030, 10 years from now. Right. The figure, these two, I wish I had put both the slides side by side to have compared it, but doesn't matter. You could always put them and have a look to see where we are changing. Look at this. Paraxylene, where we are, paraxylene, we must have gone up somewhere, paraxylene has gone up, right? From down. Ethylene, we are here, ethylene has gone up. Propylene, here like this, purified terephthalic acid. PTA has gone up, right? And what else? Propylene also has gone up, right? Now you see, below the line, polystyrene, butadiene, benzene. Polystyrene, butadiene, benzene. Only thing is, they are expected to slightly go up as compared to this. Yes, as compared to this, there is, of course, there is going to be a boom there in the demand in the next 10 years. So all these things are all now up now with a bigger scale. Okay, so can go through it. And petrochemical is an ideal make in India opportunity. Atmanirbhara. Petrochemical intermediates are ideal candidate for make in India, right? Strategy because of several reasons. First, they are a vital link in the Indian chemical industry. Intermediates such as ethylene oxide, propylene oxide, polyol, phenol, acrylic acid, styrene, and rubber derivatives are the primary feedstock for producing specialty chemicals, which are essential for manufacturing almost all consumer and technology products. The four reasons. Second reason, India has been facing significant shortage in almost all petrochemical intermediates. This has led to import dependency of 45%, one of the highest in any manufacturing industry. So it's time we come down to make in India. Third, petrochemical intermediates offer a significant growth opportunity driven by downstream industries and what is this? The specialty chemical industry is poised to undergo a rapid growth over the next decade and will be the primary driver for demand in petrochemical intermediate. Growth in specialty chemicals will stem from both the growth of end industries. Sir, what is this? So specialty chemical industry requires, there's a lot of scope for make in India. Fourth, the petrochemical industry is a highly value creating one. Lot of money is there in it. All right. It has delivered return to shareholders 50% higher than the average Indian corporate sector. Wow. Right. Have shares in petrochemical companies, you have made your money. If its full growth potential, if its full growth potential can be unlocked, it could generate yet another further value by boosting entrepreneurship, technology and research and development, and by unlocking latent demand in downstream industries. So those of you who have dreams of becoming an entrepreneur, pick up one of the petrochemicals. Lot of opportunity and money is there. Petrochemical intermediate produced using petrochemical building blocks such as ethylene and propylene are a vital link in the Indian chemical industry. Intermediates like ethylene oxide, propylene oxide, polyols, these are intermediate, meaning they are not, see, you and I don't consume ethylene and propylene, but we do consume polyethylene and polypropylene. That is why ethylene propylene is the intermediate. Similarly, ethylene oxide, propylene oxide, polyol, phenol, acrylic acid, styrene, and rubber, they are not consumed by you and me, but the products which are made from these intermediate chemicals are consumed by us. Right? They produce whole lot of specialty chemicals. These specialty chemicals are essential to manufacture a vast majority of consumer and technology products required in the economy. Examples of petrochemical intermediate. You see, these are the building blocks, BB. Methanol, ethylene, propylene, C4 means the butadiene, C5 pentane, and benzene, toluene, xylene. So you can say, these are the building blocks of the petrochemical raw material, and they all can, ethylene, propylene, benzene, toluene, xylene, mainly come from the refinery, right? And methanol, of course, could come from the syngas, carbon monoxide and hydrogen, right? So we know how to do it, right? And petrochemical intermediate, these are all intermediate. Acetic acid, vinyl acetate, acetic anhydride, acetate ester, ethylene oxide, glycol, ethoxylate, ethanolamine, monoethanolamine, diethanolamine, don't forget glycol ether, cumene, phenol, acetone, resin, propylene oxide, polyol, propylene glycol, acrylic acid ester, superabsorbent polymers, SAP, superabsorbent polymers, SBR, styrene butadiene rubber, PB, polybutadiene rubber, NBR is what NBR? PCR, just check that up. NBR and PCR, we are getting it first, I think. NBR and PCR is not listed here. Okay, they are rubbers, right? Special rubber, nitro rubber, I think, right? And ethyl benzene, styrene, ABS resin, bulk plastics, polyethylene and derivatives, polypropylene, polyvinyl chloride. These are all intermediate, right? Intermediate for bulk fibers. Then I have my end product, specialty chemicals, plastics, compounds and composites, fibers. And my end use is there in agriculture, consumer good, construction, food and feed, electronics, energy and utility, packaging. So these are my building blocks. These are my end market. These are my intermediates. And from these intermediates, I go to these end products from where these are my end markets. Wow. In the petrochemical industry, the organic chemicals produced in the largest volumes are methanol, ethylene, propylene, butadiene, benzene, toluene, all this we listed here, xylene, ethylene, propylene, and butadiene along with butylenes are collectively called olefins. Ethylene, propylene, butadiene along with butylene They are olefin, which belong to a class of, I think this is butadiene, right? Are collectively called olefins, unsaturated hydrocarbons, which belong to a class of unsaturated aliphatic hydrocarbon having the general formula CnH2n. Olefins contain one or more double bond, which make them chemically reactive. Of course, ethylene, propylene have a single double bond. Butadiene has two double bonds, right? 1,3-butadiene, one double bond on the first carbon and one on the third carbon, right? Benzene, toluene, xylene referred as aromatic or unsaturated cyclic hydrocarbon containing one or more ring. Olefins, aromatics, and methanol are precursors to a variety of chemical products. Olefins, aromatics, olefins, remember, ethylene, propylene, butadiene, right, and aromatic, benzene, toluene, xylene, and methanol. They are precursors to a wide variety of chemical products and are generally referred as primary petrochemicals. Look at the world demand, world consumption of primary consumption, world consumption of primary petrochemicals, right? These are all the primary petrochemicals, olefins, aromatics, and methanol. Like, look at this. Almost 50% of it is in Northeast Asia. Northeast Asia, Japan, Korea, Hong Kong, all those are in Northeast, Thailand, Northeast Asia, right? Northeast, so you know the countries from the map, Northeast Asia. Then comes North America, that is the USA and Canada. Then Western Europe, England, France, Spain, etc. Then Middle East, all those, UAE countries, Dubai, Kuwait, and Vagera. Southeast Asia is where, Thailand, Philippines, and all are. Northeast Asia is primarily Japan, Korea, North Korea, South Korea, and Hong Kong, right? Southeast Asia will be what is that? Thailand, Philippines, and what else? Southeast Asia. Check whether Vietnam could be also under the Southeast Asian countries. Then Indian subcontinent. Ek tukda hamara bhi hai. Indian subcontinent includes India and Pakistan. This the violet is all the remaining. So we have, of course, Asia is there, and India is also having a good share of the primary petrochemicals consumption. By 2020, look at this. World consumption. Ethylene, huge. Then propylene, ethylene, propylene, then methanol, xylene, benzene, toluene, butadiene. So 1, 2, 3, 4, 5, 6, 7. These 7 petrochemicals, we have to capture them. How ethylene, propylene, methanol, xylene, benzene, toluene, butadiene, right? Capture them. Basic chemicals and plastics we are coming to an end, are the key building block for the manufacture of a wide variety of durable and non-durable consumer goods. Considering the items encountered every day, the clothes we wear, kapda, construction materials, makan, used to build homes and offices, a wide variety of household appliances and electronic equipment, packaging for food and beverage, and many products used in various modes of transportation. Chemical and plastic materials provide the fundamental building block that enable the manufacture of most of these goods. Demand for chemicals and plastics is driven by global economic conditions, which are directly linked to demand for consumer goods. Although investment in new chemical assets are occurring on a global basis, the primary focus over the past decade has been in mainland China, Middle East, and North America, each with its own unique drivers for these investments, including fast developing markets and domestic energy and feedstock advantage. So North America and Middle East, they are exploiting the gas reserves they have. Mainland China's investment has been focused on coal to chemicals production and on purpose. So China is more focusing on producing many of the chemicals from coal. Remember, from coal tar also, I can do benzene, toluene, xylene, right? So not necessarily from refining. My coal, what is that? In the coal technologies we have seen, coal tar distillation can also result in a whole lot of aromatics, benzene, toluene, xylene. So China is focused on coal to chemicals production. The Middle East originally focused on oil and gas export. Now they have begun to see. Earlier, the Middle East countries were exporting all their oil and gas. Now they have become smarter. Now they want their own refinery and they want their own petrochemical plant so that they will export the petrochemicals to other countries and make more money. Right. I think you check up SABIC Plastics, SABIC. They are one of the big names from Saudi Arabia. Right. These units are large scale, relatively new, and forward integrated into derivatives. Forward integration. Forward integration means I don't make a product which is not which will be the input for some other making, right? So that I don't depend upon, I reach up to the end consumer product. That is forward integration, right? The developments in North American non-conventional oil and gas markets have reignited the investment. And USA, there is a lot of shale gas discovery. Shale gas discovery means shale is something similar to the seashells you find on, the seashore, etc. So shale gas discoveries in the United States and Canada, right, have significantly increased the supply of natural gas liquid, which have transformed North America into a low-cost region for chemical production. A high number of global chemical companies are expanding, building facility or expanding or building new facilities in North America. The petrochemical industry continues to be influenced by globalization and integration of world economy. Present COVID-19 pandemic, which is affecting every region of the world, is expected to have a significant effect on economies in 2020 because of strict government-ordered lockdown, travel restriction, and diminished trade flows. Pucho mat, we know the hardship. 1 year we have gone through this horror. Top 10 petrochemical companies in India. Reliance Petroleum, Indian Oil Corporation, IOCL, Haldia Petrochemicals, West Bengal, Paschim Banga, Finolex, Ratnagiri, Gas Authority of India, they have in several places. National Organic Chemical Industry, NOCIL, 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 Maharashtra, DCW. It was originally known as Darangadara Chemical Works. Now it is abbreviated to DCW. It is in Tamil Nadu. Bongaigaon Refinery and Petrochemicals, BRPL. Right. Manali Petrochemicals, right, Chennai. IG Petrochemicals, check the location. Okay. Petrochemical manufacturing basis. From natural gas, I do processing. I can get ethane, propane, butane, right? And from this, I put to a ethane cracker. I can get ethylene, propylene, butylene, etc. And these are the base petrochemicals, right? Ethylene, propylene, butylene, benzene, xylene, toluene. So from crude oil, I can go to refining and get naphtha, and the naphtha can go to a naphtha cracker and then reformer, and from the reformer I'll get benzene, xylene, toluene. So my base petrochemicals I can come get through gas route as well as through the crude oil route. Okay. Then raw materials and feedstock. From natural gas, I can go to methanol. You know from natural gas how to do steam reforming or partial oxidation and make carbon monoxide and hydrogen, with which I can make methanol. And from natural gas, I can also pick up some ethane, propane, butane, and then get into ethylene, propylene, right? And from naphtha, from crude oil, I get naphtha, and from naphtha also, I can get these light gases by cracking of naphtha, and my cracking of naphtha also will give me butadiene, right? And after cracking, I may use the naphtha for reforming, and my reforming will give me benzene, toluene, xylene. So broadly, we know what are the petrochemicals and where to get it from. The petrochemical tree feedstock, this again summarizes from crude oil and natural gas, what all we get. The figure we have seen earlier is put in different format. So from methane, I can get syngas, from which I can get methanol and ammonia, my gateway to many chemicals, right? Or from here, where is this? I get propane by steam reforming, I get olefin, right? Steam cracking, right? So ethylene, propylene, butadiene, so I do reformation, the what is that? Catalytic reforming. I get xylene, toluene, benzene. There it is. So we know then class agenda for the next three lectures. We are going to have a crack on all these things: ethylene, propylene, butylene, benzene, xylene, toluene, and some of these no intermediates. Where are those intermediates? Yes, some of these intermediates. Okay, so we'll come to it. That's it. Thank you all and have a great day and keep celebrating and keep achieving. Be dreamers, performers, and achievers. And all my very best to you all. Thank you all. Thank you. Thank you.
Thank you, sir.
Okay. I hope you enjoyed the Women's Day celebration. हम छोड़ेंगे नहीं आखिरी दम तक लड़ेंगे. I would have done it here in the classroom, but मौके का हालत ऐसा है. Okay, so thank you all. Have a fine time. Bye. Bye.